Thanks for joining, guys. This is a giant 555 timer circuit from Evil Mad Science Laboratories. So just going to be building it up. Try to explain a little bit of the circuit as I go. Start out with the resistors because those are the easiest to get on when before the transistors go in. Okay, make sure this is what I was expecting it to be. This is a 4.7K. Hey Pedro, how's it going? Okay. Just wanted to make sure the resistor was what I expected it, so I checked it with my multimeter. Now, what would be nice is if I had a resistor bending tool. In fact, I 3D printed one a while ago, and of course I can't seem to find it. So that's alright. Just try to bend the leads to about where they should be. Now, the 555 has been around a really long time. It's actually one of the oldest integrated circuits. And what's really cool about this kit is that you can kind of see that the IC is really not that complicated. You know, it's only okay. So right now I'm just placing the 4.7K resistors all around. It looks like there's 8 or so of them, and then after that I'll do some of the more unique values. This kit's really cool because everything is nicely labeled. It comes with some pretty clear instructions, and in a lot of ways, if you've never soldered something before, this is probably a really good kit to start out with, just in terms of how it's laid out, how easy it is, and then when you're done, you end up with this really cool 555 circuit. So that by itself probably makes it worthwhile. Okay, 1K, 10K, 4.7K. Now what's interesting they used on the silk screen on here is they used 4.7K instead of 4K7, which I'll see sometimes. One nice thing about saying 4.7K is that different parts of the world that don't use decimal points don't get quite as confused. Alright, I totally botched this resistor. That's what I get for bending it with my finger instead of the needle nose pliers. I really wish I could force this thing to refocus. Oh well, this one's just going to be a little bit awkward looking. If you're new to electronics, I do actually have a YouTube channel that talks about, has some video tutorials on how to, some of the basics. And so if you go to AddOhms, that's ADDOHMS.com, you can actually see some of those tutorials. I tried to do something that was a little bit different, and they're actually animated, so they're actually called whiteboard animations. A lot of fun to make them. Done about 15 so far. Personally, the first few are a bit difficult to watch because I'm still trying to figure out how to get them going. Almost 4.7s. So what I did to do is go ahead and put together down all the resistors at once, flip the board, solder them real quick, and move on to the resistors. There should be more 4.7K. 1K, 100. No, I think traditional iron. Thanks, Wilmer. I tried to build solder ones. I was at the apartment. All right. So as exciting as that so far, now if we do, there's a bunch of these more single value resistors. Get those done, then we'll actually go ahead and solder up these now. So I'm going to flip the board over. What you'll notice is I was taking and putting leads at a 40-degree angle. Basically, I wanted to make sure that once I flipped the board over, the resistors didn't move too much. Now, sometimes, depending on what I'm doing, I might actually try and solder them on the component side just to get them to stay in place. But I decided just to do the bending today. And just for the record, I'm not a believer in lead-free solder. I'm more of a leaded solder. It just works so much easier. Of course, this solder that I'm using is almost 15 years old, and so the flux is not nearly as good as it once was. For small stuff like this, it's no problem. But if I try to do any kind of like large stuff like this, it's no problem. If I try to do anything that's like fine pitched, I usually end up with just a solder mess. But I do have a roll of newer solder that I use for that kind of stuff. All right. Now I could probably be doing a little bit better job with the solder joints, but let me try this. All right, I think those are all good. Okay. Now, if you're new to soldering, just, this is kind of obvious after a couple of times, but you sort of want to hold on to leads when you go and clip them. Otherwise, they're going to go flying off in a strange direction. It's also one of the reasons I recommend when you're getting started that you wear safety glasses. Or if you're already wearing glasses, you're probably okay. But if you, especially the bigger leads, don't tend to fly quite as much. But if you get like a small lead or like a surface, or not a surface, but like an IC, the little bits can just go flying almost anywhere, and that's probably not so good. All right. The device I'm using to hold the circuit board is actually a panel device, and you can kind of see down here I've got a basically it's just an iron block, and it actually holds it in place for me. I don't have a big work area, and so I didn't want to screw the vise into my bench, and so this weight is just enough to hold most circuit boards without rocking around too much. The surface I'm using doesn't really do so well with with the suction cup, which is what I used to use. All right, so let's see what some of these single values are. Okay. All right, the 820, bend that one. Now, for the camera setup, I'm actually just using an iPhone 5, and it was my original iPhone 5. I never sold it because the screen is cracked. And so earlier this morning, I did a video on 3D printing a bracket for it. And so that bracket's actually holding it in place right now. It's kind of like a tripod mount. I have another mount that I've printed for my GoPro, and that's the two together are actually holding the camera right now. All right. That's a 1 kilo ohm. Let's go forward to 10K. So it looks like the 10K is over in the comparator. A couple of years ago, there was actually a contest for 555 circuits and different things that you could do with them. I usually use them to do things like blinking LED, but there's all kinds of different things you can do. I've actually seen a circuit for Pixie or Nixie clocks, well, basically Nixie tubes, and the 555 was what generated the high voltage. 100K. These leads actually have a little bit of a smaller pitch than the 1K resistors did. I wonder if looks like they're a little bit smaller too. They must be rated for less power. All right, anyone see where the other 100K went? It's right here. Okay. Uh, 15K. Don't see. I see 100.9, 6.8. What was it? 15 ago. 3920, 6. 15K. Point 8. It's an easy in the flip circuit page. 3.9. Okay. All right. 220. That one a couple times. Or at least I thought I did. Now I don't see where it's at in the circuit. There we go. 220. And 100. So when I get this thing built up, I'm actually going to take a look at flashing it with an LED. I've got an 555 I've already breadboarded. I'm just going to basically swap out that chip for this mega chip and see how well it works. Alright, this is the last of the resistors. Then we can get on to the more fun transistors. A couple quick taps of solder. The PCB that this kit is using is actually really nice, high quality, pretty durable. I don't know if it's standard FR4 or if it is, if it's just a couple of extra layers, but it definitely feels thicker than most traditional PCBs, which is probably good if that's the case, because then the through holes are plated a little bit better, which ultimately makes it a little bit easier to solder. So if you're getting started and not so good at making the solder joints, they'll actually hold up for a while. All right. All right. Easy enough. Alright, so all the resistors are soldered on. I'll flip this back over so we can see it. And the really good news is that my resistor pile is empty. So I think that means we didn't miss any. Missed that solder joint. No problem. The soldering iron I use is a Heiko 888. I think it's probably one of the best soldering irons I've come across that doesn't cost a fortune. I mean, there's definitely better out in the market, but you end up having to really pay for them. This one heats up pretty well, seems to hold its temperature. Has a couple of different tips available. The tip I'm using is actually what I call my bigger tip. I have one that I use for fine pitch work that is amazing. It also heats up pretty quick. The only thing I don't like about it is the LED is off when it's heated up and on when it's heating, or flashing when it's heating. So sometimes I forget that I leave it on, or don't realize I've left it on. Alright, looks like I missed one more solder joint. So the clamp I use is a Panavice clamp. It's actually three different pieces. There's the base, which is really just a piece of solid iron. And then there's, I forgot what they call this one, but this is the standard head. That's the standard head. And then I'm using the circuit board attachment, which, crazy enough, holds circuit boards pretty well. They make a different one that has a couple of black clamps, and that's actually pretty nice as well. I just haven't invested in one yet. So we go take a quick look. The only spots that are left are for the transistors. And so the way that this is actually built, if you can see it, there are two types of transistors used. There's either a 2N3906, which is a PNP, and then there are 2N3904s. We're back here. the two N3904s, which are an NPN. Both are BJTs. If you go to atoms.com, I actually have a video on how those BJTs work. And so there's 3 different connections, and we can see that this board is very clearly labeled EBC, emitter, base, collector. Every one of them has that. And then there's a certain pattern to the silk screen, and so it's a half circle with a straight line. And what that's telling me is I need to match up the transistor to the same thing. And so the transistor has a flat surface, and then it has a rounded surface. And so all we need to do is make sure we've matched those up. So there's 2 things we have to watch. Do we match up the flat to the flat? And if we put a 3904 into the 3904. So to keep things straight for me, I'm going to only do the 3904s first, and come back and do the 3906s. Nice thing about the 3 legs, they'll actually kind of stick in place without much trouble. Right. We don't want to get any paper inside the holes, because then they'll just get caught up in the joint, and then the joint won't work so well. Right. So again, this kit from Evil Matt's Laboratories, ESL. You search Google for that, you'll probably find Twitter, if not the page. All kinds of really good kits. Next, I'm going to do one with they have an op amp. In fact, I was that one first. A little bit. I think it's a little bit better, but I didn't have a circuit pre for it, so I went with this first. But it's kind of amazing how often this 555 timer gets used, and it's a really simple circuit. It's only a handful of transistors, a couple of resistors, and that's it. That's all that's inside that little package. Of course, it's all on silicon, and so it's all integrated together. But yeah, it's 3904. All right, so I've got 3 more left on my strip. And then I'm going to double check to make sure. This one's interesting. It's backwards. So that's the first one that doesn't face the same way. And it looks like I've only got 2 more left. Okay, so out of these, so now I just want to go around and double check my, so 06, 06, 06, 06, 06, 666, 6, and then 1, 2, 3, 4. All right, so it doesn't look like I missed any. So just like with the resistors, I think now's a good time to go ahead and solder those on. I'm going to tin the, I'm actually going to clean this completely. I'm going to tin up my tip a little bit just to help these go by quicker. Now, resistors are pretty resistant, no pun intended, to heat and abuse. Transistors and integrated circuits, on the other hand, they are a little more sensitive, and so you want to be careful how long you're keeping your soldering iron on. Yeah, if you're having to hold onto a lead for more than 5 or 6 seconds, that's probably too long, and that can easily damage the the silicon parts inside. So just keep that in mind. If you're having trouble making your solder joints, back up, double check what you're doing, make sure you're getting good surface contact, and that your solder has some flux in it. If you're still having trouble, you can't quite get a technique down, there are these what they're called flux pins, and they're basically a pin with a sponge inside that has flux, and so it's liquid. You just kind of press it onto the board, and it'll help to distribute the heat from your soldering iron. The downside of them is that even though they're usually a no clean style, it leaves a significant or a lot of residue on the board. So okay. Now, in theory, this solder residue, which you can actually see it's kind of this stuff around here. That's a bad joint. The residue is not supposed to be conductive, but you'd be surprised how many times I run into a situation where the flux itself actually created a conductive path between two pins and was causing all kinds of problems. Now you might not be able to see it on the Periscope, but one of the things I'm trying very hard not to do is when I'm making the solder joint, I'm not letting the solder touch my soldering iron directly. I'm trying to melt it through the joint and through the pad and through the wire. And the idea is I want the heat to flow to cause the solder to melt and flow around it, and instead of the soldering iron just creating a heat bubble. That's getting a little bit dirty. Yeah, actually I just cleaned off my iron and look how much better it's working. It's another thing too is once the tip starts to get a little bit of residue on it. Again, part of what's happening is that's my own fault. The solder I have is probably 15, almost 20 years old, and so it's actually got some junk left over in it, or it's got some oxidation, I should say, and that's actually causing quite a bit of buildup on my tip. And of course, you should always, when you're done soldering, you should always tin your tip, which means just douse it with solder so that the tip itself doesn't oxidize while you're not using it. It's a way to protect and maintain the tip for a long time. If you actually go to baldengineer.com and search for soldering, I found an application note from a soldering iron company that's really good. I used to use a brass sponge when I was soldering, and this app note kind of not kind of, it actually talks about why that's a bad idea. And that's something I had never really considered. All right. Now, how fun is that? All right, let's clear up the leads. So I'm going to do for this one, I'm going to do one a little bit different. Go ahead and just cut across and get all three at once. Otherwise, we're going to be here all day like wires, and it's only slightly more exciting watching me. So let leads laying there. I don't want to do that. I'm going to leave them and flip the door. Make sure they go that way. Alright. We're in pretty good shape. Until I hit this with some alcohol to clean off the flux, it's a little difficult to do. But I think for this part, we're in good shape. Alright. Now move on to 36's P and P type, which is the complement to NP. Just going to throw these in, matching up the flat side to the flat side, just like we did it before. Now, sometimes, if you're new to transistors, it might be a little bit confusing when to use a PNP versus an NPN. And unfortunately, there isn't always an easy rule of thumb. It really comes down to how you're switching things on and off. And so you really just have to kind of think about what you're trying to do, what are the voltages available, and that's going to help direct you towards the right transistor type. Okay. Really like to have music playing in the background, but I'm not really sure what the licensing restrictions on that would be. And I have a feeling most people don't care. Alright, so yeah, so most of the 3906s have their flat side facing this way. And there's a couple that are facing the other way, so just got to make sure we don't miss that. When I said a couple, I guess it's just this one. Huh. Alright. Alright. Solder these up, and we can move on to the mechanical portion. So just as a check, this is what we're building. That's what it'll look like when we're done. Go. Must be a resistor right next to that transistor. I don't remember seeing that on the other side. one of the hardest parts for soldering for me is that I really like to drink a lot of coffee. And on days like this, when I know I'm going to be soldering, or at least soldering quite a bit, I try to avoid the coffee. And so that's always kind of a bummer. That's probably what I'll have a nice glass, or a nice cup, nice glass of coffee. But you don't really realize how much caffeine causes you to shake until you start trying to do something fine motor pitch like this. Alright, 2 more to go. Pretty excited. I actually always wanted to build one of these myself. The 555 has always just fascinated me with the simplicity of the circuit and how flexible it is. And so I've always wanted to make a big version. So when this kit came out, I was really excited because, I mean, this is really cool, right? I mean, you get to actually see how this thing works. We can go poke multimeter or scope all around and inside of the circuit, which is really, that's going to be kind of cool. All right, starting to get a little bit of flux on my finger. Pick this guy up. Oh, darn it. Darn it, darn it. All right. So, take one more look. Happy about this one. This guy. Remember another one over here. Look at me. All right. All right. I think for the most part, we are good. So, that is the 555 so far. Alright, and now what we're going to do is attach the legs. And this is really cool. Check this out. So inside the kit, there are these huge legs that it uses. And so we're going to attach those to the circuit board. Alright. So